Hello math students, you've been assigned some IXLs today and I wanted to go through a couple of examples maybe from each one to ensure that you can work as efficiently as possible. So your first IXL is on solving absolute value equations, and the main thing I wanted you to understand is that every one of them is going to have two different spaces for answers, but even if you only end up with one answer, such as like if you had absolute value of x equals 0. Well, there's only one answer for that. You still will have two spaces, but you can just put the one answer in and then click submit and it'll count it right. So you don't have to have two answers for it to count it correct. So this example, I would just turn this around. Isolate the absolute value. So the absolute value of s equals 1. And then you split it, s equals 1 or s equals -1. So you put a 1 in one space and a -1 in the other space. Another example looks like this. You have to isolate your absolute value first. So after you do that, you have absolute value of t minus 1 equals 3. And then you separate it. And then solve for t. So t is 4 over here, and t is, what is that, -2. Okay, so that was the equations. The next one is the inequalities, and this was the one that most of the students in my second period had trouble with because we separated the less than problems and we separated them into two, but they want to see it like this. So if you isolate the absolute value and you have a less than, then they're going to want to see it in a compound inequality format. If you have a greater than, they want to see that word or typed in here. So let's look at this one. I'll show you what I'm talking about. Absolute value of u minus 6 is less than or equal to 4. I'm going to go ahead and add 6 on both sides. Okay, so now I've isolated my absolute value and I have a less than symbol. So my less than symbol is one of those and inequalities, but they don't want to see the word and. What they want to see is they want to see something like this. So it's going to end up looking like this. And here's how you can do that. Take this number, take the opposite of it, and put it on the left. So -10, and then do your less than or equal to, and then your u. And then everything else is going to look just like this, except without the absolute value bars. So instead of writing u is less than or equal to 10, and u is greater than or equal to -10, all we did was we turned this thing around. So if you turn this around, -10 is less than or equal to u, then you can combine these two. If I move, so let's say I move this one over here, -10 is less than or equal to u, and then I put this one here, u is less than or equal to 10. Well, those can go together, so that's really what you're doing. But the shortest way to do that is to take this number, take the opposite of it, put that less than or equal symbol, the variable or the absolute value in there, and then everything else is exactly the same as it was. So anyway, that's what they want to see. So they're going to want you to type in -10 less than or equal to u less than or equal to 10. So that's what they want to see instead of the and. You're not going to type in an and at all. Actually, they have the and there, but you're not going to be typing in an and if you get a less than. Okay, so let's look at another one. So this ends up being absolute value of b is less than, and then we're going to add a 7 over here, 4. So I could, if I separated them, I would write b is less than 4, and I would write b is greater than -4. So if I turn this part around, -4, and this is less than because it points toward the -4, less than b, and then I wrote this one, b is less than 4, then I could combine them and just put the b in the middle. -4 is less than b is less than 4. And they work because negative 4 is to the left of 4 on the number line. So that's what they want to see there. Negative 4 is less than B is less than 4. Okay, the next one, let's see. Okay, so this is one where I'm going to divide on both sides by negative 4. If I divide by a negative number, remember, I have to switch that symbol to, I have to reverse the symbol. So then I have, let's see, negative 7c plus 5 inside the absolute value is greater than 2 because I have divided by a negative number. Negative 8 divided by negative 4 is 2. So now that I've isolated this, I realize that this is a greater than problem, and so I'm going to be using the word or when I type in my answer here. So let's go ahead and split this up. Negative 7c plus 5 is greater than 2, or negative 7c plus 5 is less than negative 2. Okay, so then let's just solve each one. Subtract 5, negative 7c. I think it's going to switch the other way, but that's okay. Negative 7c is greater than negative 3. Subtract 5 on both sides. It is going to end up switching, but I think we're still going to have an or statement. Let's see. Divide by negative 7. C is, and then I have to switch this again because I just divided by negative 7. C is less than 3/7. And then let's see, let's subtract 5 here. I have to see what we end up with. Less than negative 7, divide. Switch this again. C is greater than 1. Oh yeah, it's still an or statement because 3/7 is to the left of 1 on the number line. So this would be one that would go this way and this way. So that is an or statement. So what you would type in is C is less than 3/7 or C is greater than 1. So if you have this, the greater than, again, you're gonna be using that word or. Let's see if we have another one. Here's another one. Okay, let's isolate the absolute value. When you divide by negative 3, switch the symbol. So let's see. 3D is less than 5/3. 3D is greater than negative 5/3. So this is one of the and statements. I'm going to flip this one around. So you can see that this is going to go in the middle. If you don't have to write all this part. Once you get to this right here, take the opposite of this, negative 5/3, less than 3D, less than positive 5/3. Now just multiply everything times, divide by 3. Which is the same as multiplying by 1/3. So that's D in the middle. That's going to be negative 5/9. This one was not fun. And this is going to be 5/9. Y'all let me know if I made an error on that one because it doesn't look right. Something doesn't look right about it, but I think it's right. So you would enter negative 5/9 is less than, D is less than 5/9. So this was the transformations. Hang on a second. Here's the next one was graphing solutions to absolute value problems. So this one, let me get a, hang on. Okay, now I can write on this page. So we have absolute value of b plus 2, and I'm just switching these around, less than or equal to 5. So b plus 2 is less than or equal to 5. b plus 2 is greater than or equal to -5. And this is an and, but we can solve them separately. b is less than or equal to 3. And b is greater than or equal to, that's -7. So this is in between, because less than 3 and greater than -7 can occur at the same time. So we would rewrite this. If we were going to write it, we don't have to do that. Like that. So it's in between those two numbers. So then when I want to graph that, it's -7 is included. 3 is included, so I would just make this go up to 3. And if you want to change these from closed circles to open circles, you just click them more than once. Let's see if we got it right. Okay. All right. And then your last section is transformations. So it looks something like this. G of x equals, and then all it says is it's reflected across the x-axis. So let me get I don't need my pen. So this is going to be, let me get rid of that. Oh, I can't. It's going to be a negative. And then your x goes in here. And that's it. It's just a reflection across the x-axis. Okay, this one says 7 units right, 7 units up. There's no reflection or anything. So we have x, 7 units right is going to be -7. And then on the outside of that is going to be +7. So that's what that one looks like. Okay, just let me know if you have any questions. I'll be glad to help you with any of these.